Hi everyone, this is E.M.P, Electromagnetic Precursors for Earthquakes. And here's the usual TEC, aka ionospheric electron density maps that I usually use, but as we've established in previous video that this is simply ionospheric charging or capacitance. Black and blue areas and white and red areas are under extreme charging or capacitance, so this is looking at the 14th of August. Jumping over to the 15th, you can see Japan really highlighted in both maps, especially when you're seeing these areas adjacent to one another, the black and the blue and the red and white areas. You're pretty much guaranteed you're going to see earthquake activity go up following a few days up to at least a week afterwards. And if you've been following the earthquakes, that's exactly what's been happening. Just one thing before we get started on that. There was a huge earthquake, magnitude 7.5, South Georgia Islands on the 19th of August at 7:32 Universal Time. And looking at the gamma rays on the 19th, you can see it's a pretty big spike there at about 700 Universal Time. So just about half an hour or so before that earthquake hit. And looking at Beijing's magnetometer, so remember, once again, this is ground-based observation of magnetic activity or precursor, and you can see that right when we had that gamma ray spike around there, magnetic activity shot up huge, so that's definitely an electromagnetic precursor for earthquakes there. And just to refresh, remember the capacitor model, you can compare it to the plasma lamp that we all know and love. The outer glass sphere would be the ionosphere, the interior sphere here would be the ground. Both are susceptible to charging from the galactic and solar circuit, which gamma rays and cosmic rays come into Earth from and link up with our magnetosphere and ionosphere, and in between in this area would be the dielectric discharges. So you can think of these dielectric discharges as cosmic lightning. And this was ionospheric charging the day before that earthquake in South Georgia Islands, and you can see that it was right on the edge of this elevated capacitance there. So here's Argentine Islands. This was the closest magnetometer to the Georgia Islands earthquake, and you can see there was a large bump in magnetic activity just hours before the earthquake at about 0300 to 400 Universal Time. And jumping back to gamma rays, there's definitely elevated activity there. And more gamma ray activity. So that's definitely what set off the magnetometers. So, like I was talking about in the previous video, science doesn't understand really on any level yet, is that these dielectric discharges or neutron spikes can set off magnetometers literally all around the globe. When you're talking about electromagnetic fields, dielectric discharges, distances literally nothing when it comes to this extreme levels of energy impinging on the ionosphere and setting off earthquakes. And next one I wanted to show you, so there's a magnitude 6 earthquake on the 20th of August at 9:01 Universal Time. And looking at the gamma rays, you can definitely see we had many spikes leading up to that earthquake around there. And there's a huge spike there, basically right at the time of the earthquake, so that's instantaneous action at a distance. You much guarantee you're not going to see this data anywhere else. This is some of the craziest data I've ever seen, and we're just getting started here. So sort of that, and as you can see, big ramp up in magnetic activity there at about just before 0600, and then again at just after 0900 Universal Time. So jumping back to the gamma rays, you can see the spikes synchronized with the magnetometer there. And like here I showed already, many spikes. So this is all synchronized with the magnetometers, which is ground-based observation of magnetic activity, aka precursors, and that's exactly what we're looking for. And jumping to the 21st of August, magnitude 5.1 in Japan again at 12:46 Universal Time. So there's a spike there at about 0900 Universal Time again. And then elevated activity there till about 300 or 400 Universal Time. And here's looking at Japan's magnetometer, and you can see starting at about 0300 Universal Time that magnetic activity just ramps up and continues on until we had the earthquake just after 0900. So there's a ground-based observation. And then on the 22nd, another earthquake at Japan, magnitude 5.5, 9:33 Universal Time. Boom. Yeah, it's definitely one of the craziest ionospheric charging maps that I've ever seen, and like I've pointed out frequently in my past videos, this is caused by gamma rays and cosmic rays. I'm showing the gamma rays because they're really the highest energetic bursts, so-called, but they're actually dielectric discharges that flow in by circuits via the galactic circuit and link up with the solar circuit. And we had 2 consecutive gamma ray bursts at the end of August the 21st. One coming out of constellation Draco and the other one out of Ursa Major. Just about an hour or two between these gamma ray bursts, dielectric discharges. And I've seen this happen before. You could pretty much guaranteed when you're going to get 2 consecutively like that. The ionosphere is going to, right after that, this is only about 4 hours or so after the gamma ray bursts, and that is definitely the effect. So, jumping back to the gamma rays, you can see spikes here, right when those gamma ray bursts went off, and then right there again at 0100. Remember, the 0100 is the time when we usually get those intervals of extreme ionospheric capacitance, and we're on the 22nd at about 1000 universal time. The dielectric discharges really started going off at that time. This is reaching about 30,000 neutron count levels, which is just effing insane, to be honest. One of the largest discharges, or neutron spikes as they call it, that I've ever seen. No joke, folks. So that is definitely what's going on here in the ionosphere. And here's another map for the 22nd of August, 0100, literally lighting up the entire equator, equatorial zone, and then some. So that quake was at 9:33, so the 22nd. There you can see gamma rays once again causing, this is in India's magnetometer. So just to show that it not only can set off magnetometers right there, but also at a distance instantaneously, very easily for dielectric discharges of that caliber to do that. And then here again at Japan's magnetometer at around 0600. Right where we started getting some spikes. Gamma rays, which are dielectric discharges. And here as well, we got some more discharging going off there as well. So that's pretty much all I wanted to show you, folks. Don't want to make this video much longer than that. Moving on to the 23rd. This is literally the craziest ionospheric charging interval that I've ever seen. We'll save that for the next video, but yeah, sorry, I've just had lots of caffeine and gamma rays and capacitance, and we'll leave this for the next video. So stay tuned, folks, and take care. Thanks for watching.